Hello, my name is Travis Humble. I'm the director of the Quantum Science Center at Oak Ridge National Laboratory. My background is in theoretical chemistry, but for the past 2 decades, I've been working at Oak Ridge National Laboratory on the development of new quantum computing technologies. Quantum technology is very exciting, but it also brings many different challenges. Some of the most fundamental relate to noise in the physical system, errors that occur when we're trying to use those systems, as well as scaling up those technologies so that they can meet these large-scale requirements for demonstrating applications in, say, a quantum computer. The Department of Energy established the National Quantum Information Science Centers in 2020 as part of their response to the National Quantum Initiative. Both the Quantum Science Center, headquartered at Oak Ridge National Laboratory, and the other 4 centers, also headquartered at national laboratories, work together to address these challenges of noise, error, and scalability in quantum science and technology. Each center attacks a distinct challenge, but we do work together in order to push the entire field forward. We see our role as partners for the National Quantum Information Science ecosystem and also focal points for ways to grow that ecosystem, to engage with our partners across the country, and of course to create the next generation of scientists and engineers that will be able to solve these challenging problems. The 5 centers have been working with industry in order to both support the understanding and use cases of quantum technology, but also to disrupt the way in which those technologies could be developed. The Quantum Science Center, for instance, is looking at new types of materials that could be used to create fundamentally different quantum computing platforms. These platforms are not yet commercially available, but in the future, if we are successful, they would be able to fundamentally disrupt the scalability and error challenges that we're facing. Being the director of the Quantum Science Center, I've noticed that there's a vast number of skills and talents needed in order for us to advance this field. Quantum science and technology is multidisciplinary. We need expertise from, of course, computer science and physics, but also mathematics and engineering, materials science, optics. All of these disciplines together have to work in order to address these challenges around noise, error, and scalability. So my role as director has actually been coordinating a lot of those efforts, and it's remarkable to not only see the enthusiasm with which everybody is willing to collaborate with each other, but also some of the challenges. We're still learning the language that we need to use describing this exciting new area of quantum science and translating that into a way that can be transitioned into new technologies. The past 5 years has been such an exciting timeline for the development of quantum science and technology that we expect the next 5 years to be an acceleration of this. Not only are we starting to see the development of scalable quantum computing systems, but those systems are starting to reach scales where they can be used for real-world applications. Compared to 2020, we believe we now have scalable solutions to creating quantum computing systems that could be used for applications in scientific discovery, energy innovation, and other areas. So this culture of quantum science and technology is actually being formed right now, and so it's exciting to be at the center of all of that.